So this is Jeff Hamrick at Rhodes College. We're continuing with our discussion about how we use a trial and error method with randomization procedures to estimate the confidence interval for the true population mean of some random quantity. In this case, the body temperatures of a group of subjects in some study. I went on ahead at the end of our last screencast and computed the empirical p-value. It's 0.006. Clearly, when I double this value, I get a value that's less than 0.05. And I'm going to build a 95% confidence interval, hence my interest in the threshold value of 0.05. So that means I would reject the null hypothesis that the data support the idea that the true mean body temperature might be 98.4 degrees. So 98.4 is still a little bit too high. The data don't support the contention that 98.4 degrees might be the true mean body temperature. To push this investigation further, I'm going to come back over to this column, right-click and edit formula, and change this 98.4 to maybe 98.35. Okay, when I rerun the entire process now, there's a fair number of dots to the left here. Let me click over here, double-click over here, and check out the empirical p-value. Now it's 0.06333. That value, when we double it, is considerably larger than 0.05, so we would not reject the null hypothesis that the true mean body temperature is 98.35 degrees. So clearly the boundary of this confidence interval is somewhere between 98.35 and 98.4. So let's continue this process and hopefully we'll hunt down a good upper bound for this confidence interval. So if 98.35 won't work, what about 98.37? We try this again. Boom. Double click over here, check out the empirical p-value. It's 0.03, which when we double is greater than 0.05. So we would not reject the null hypothesis that the true mean body temperature is 98.37. What if I push the envelope a little bit further and check out 98.38 degrees? When I run this process now, rerun the simulation, get my empirical p-value, I now get a quantity 0.019, which when I double that value, it's less than 0.05, so I would reject the null hypothesis that the true mean body temperature is 98.38. Okay? So I'll press OK here. It's going to run again. But what I want to do is change the number of measures collected so I can be really certain about what I'm doing. I'm going to change this to 3,000. Okay? And I'm going to collect more measures just so that we can be a little bit more confident about our boundary. Okay, so in this particular case, having rerun the simulation, my empirical p-value is 0.019, very close to what it was before. So I double that value. It's less than 0.05. I'm going to reject the null hypothesis that the true mean body temperature might plausibly be equal to 98.38. Let's check 98.37 again. When we check that one more time, we find that the empirical p-value is 0.027. When we double that, we're greater than the threshold value of 0.05. We will not reject the null hypothesis that the true mean body temperature is equal to 98.37 degrees. So I'm going to create a text box here to make a note about what I've done. The upper bound of our confidence interval is 98.37 degrees. Okay? Fahrenheit. Hopefully I spelled the word Fahrenheit correctly. Okay, when we get back, I'll do this in the third screencast, we'll work on the lower bound of the confidence interval. Obviously, when we're working on the lower bound, this blue line here will move over to the right tail of this randomization distribution, but I'll clarify that in the next screencast.